guys, welcome to the 2014 Year 9 Numeracy Non-Calculator Paper Solutions. My name is Maffs Guru, otherwise known as Darren Maths Guru, and hopefully these will help you either correct or work out the answers. Now, I've done this for my particular group to let them go through this and go, not only was that the answer, but that is how you got it. So fingers crossed this is going to be useful for you. This 2D shape is made from a cube and a sphere. Nope. Alright, so a cube maybe, but a sphere, nope, because that would be a whole circle. Not this one. A triangle and a circle. Are you drunk? Nope. A square and an ellipse. Nope. A square and a semicircle. That's the one there, because this is my square and that there is my semicircle, which is half a circle. Ka-ching, first question, nice and easy. Together, Luke and Emily saved $150. Emily saved twice as much money as Luke. How much did Luke save? Well, if Emily saved twice as much as Luke, yeah, that's basically a ratio of 2 to 1. So that's 3 parts. Basically, we want to split the money into 3 parts because Emily's got twice as much as Luke did, and then 150 divided by 3 gives that each part is worth $50. So that would mean that Emily got $100 and Luke got $50. So how much did Luke save? $50. Ka-ching. The length of a movie is 125 minutes. Lee starts watching the movie at 6:05 p.m. When will the movie finish? Well, 125 minutes is actually 2 hours and 5 minutes. So I'm going to add on 2 hours and 5 minutes to that, which will give me 8:10 p.m. Loving this paper so far. How many centimetres are there in 3.3 metres? Well, 3.3 metres, I times that by 100 to get into centimetres, which effectively means I jump my decimal point 2 places. So it was 3.3, jump it over 1, jump it over again, there's nothing there, and so that gives me 330 centimetres, which is this answer here. Which of these expressions is the same as m to the floaty 4? Well, I know that when I have a floaty number, that's the same as m times m times m times m. So this would be my 4th answer here. It's not 4 times m, because that would otherwise be written as m4. People will get confused with this one here, because if I've got a square monkey and a square monkey, I've actually got 2 square monkeys. And then this one here, a monkey plus a monkey plus a monkey plus a monkey would give me 4 monkeys. And ideally that's not the same as m with a floaty 4. Question number 6. There are 22 people at a party. I would not be one of them. The cost was $24 per person plus $40 extra for the cake. Which of these shows how to calculate the total cost of the party in dollars? Well, there's 22 people and they would be paying $24 each. So that's 22 times 24 plus 40. So I'm going to look for something that does that. So 22 times 24 plus 40, it's got to be that one there. Right, now they've done that in brackets first because we're really saying let's do that first. All right, this one here, nope, that would be bizarre. Don't know what that would be all about. 22 times 24 would only give you the cost that you get per person. Right, that wouldn't include the cake. And this one here is trying to confuse you because that's basically having 40 cakes for each people. I don't think so. Simon has 720 ml of juice. He pours equal amounts into 9 glasses with no juice left over. How much juice is each glass? That's effectively asking you to do 720 divided by 9. Well, 9's into 72. I think go 8 times with the 0 there. So there would be 80 millilitres in each. Now notice that I'm actually doing my working out on the book or on the paper. That doesn't matter. It's fine. Kathy buys 1 litre of milk and a loaf of bread. She pays with a $20 note. How much change should Kathy receive? Well, if we add the milk and the bread together, that's going to give me $4.90. I'm going to take that away from 20.00, so we take away the $4.90. Now again, there's lots of ways of doing this. I would basically be saying, well, if I imagine this was $5, all right, so that's going to give me 10 cents there, plus the $15, so it's going to give me $15.10. That's certainly one way of doing it. Let's just see whether we can do it the other way. 0 minus 0, put a 1 there, I'll make that 19. So 1 minus 9, 10 minus 9 is 1, 19 minus 4 is 15, and $15.10. There's lots of different ways of doing this. Money should be a good one for you guys. Which of these is 46.718 rounded to 2 decimal places? Now when I round to 2 decimal places, I tend to do a dotted line here, and I say, okay, well, is this number more a 5 or more? It is, so it makes the number before 1 higher, and all the other numbers stay the same. So it'd be 46 0.72 as my correct answer. He says changing values. This cylinder can hold up to 50 ml of water. Do you know what? This is a strange one because I don't actually think I know the correct answer, because this I don't fully understand how this has got anything to do with maths, but I think that this one is 30 milliliters, and with that one I would just have to look at it and go, well, that's a value call. All right, the chances are it's going to be fairly high up, but I'm going to come back and check that one. The Year 7 class at a school collected cans for recycling. The table shows the mass, each class collected. Which class collected the greatest total mass? Oh, okay, so we've got to add these together. So what we've got, 5.29 plus 4.56. Notice how it's getting a bit more complicated. That's going to be 15, 5, 6, 7, 8. So that's going to be 9.85. 5.32 plus 4.01. Now there might be a quicker way to do this, but at the end of the day this seems to make just as much sense for me to do it this way. 4.99, so put a 0 on there, add them together, gives me 9, 9, 10, 11, 12, 5, 6, 7, 8, 9, that's 10.29, and then 4.88 plus 5.25, 8 and 5 is 8, 9, 10, 11, 12, 13, he says, needing to rub this out. So let's do that one. 13, 8, 9, 10. Oh, I keep doing that. What's going on with this question? So let's see. 8, 9, 10. That's going to be 11. 5, 6, 7, 8, 9, 10.13. So what does it want? The greatest total mass. Well, I think that 10.29 is the highest value. And so class 7T. Right, if you can think of a better way to do that one, please leave a message on my YouTube channel. Always very happy to hear from people. The shaded rectangle will be folded along the dotted line. Where will point Q move to? That's a very good question. Now, lots of people will think, but I'm fairly sure it will actually move to point S. All right? A lot of people think it will go to point T. It actually really wouldn't, because what it's going to do is it's going to hit at a right angle and continue down to there. All right, that's a bit of a trick question. Jim picks one white ball and one black ball at random from these. He adds the numbers on the two balls he gets to get a total. Which total is Jim most likely to get? Funnily enough, one of my kids was doing this question quite recently. If we look at the outcomes of the white and the black, he says, trying to make this less bad, we would have the numbers 1, 2 and 3 on the white, and 1, 2 and 3 on the black. Now, these are basically my outcomes, and I can draw them in a table by saying, well, now if we add those values together, what am I going to end up getting? Well, 2, 3 and 4, 3, 4 and 5, and 4, 5 and 6. So those will be the totals when we do that, when we choose one white ball and one black ball. And so what we're now looking for is the number that appears the most, and it would appear to be the number 4. All right, so which total is Jim most likely to get? It would be the number 4. Jane has $5 more than Ben. Jane correctly writes this fact as an equation using J for her money and B for Ben's. Which of these could be Jane's equation? So Jane has 5 more than Ben. So the amount Jane has is the amount Ben has plus 5. So let's see if we can find that one there. J equals B plus 5. We do indeed have that one there. Right? So if I take Ben's money and add 5, I'm getting Jane. 2004 was the first leap year in the 21st century. When is the 10th leap year in the 21st century? Well, a leap year occurs every 4 years. So if we've got 10 leap years, the first leap year, when was the 10th leap year? Well, basically, if that's the first, we want to go first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. We want 9 more leap years. So 9 times 4 is 9, 8, 36. So I'm going to add 36 onto 2004. And notice how the questions are getting that little bit more tricky. So it would be 2040, right? Lots of other ways of doing this. A large block of land is divided into 12 equal sized blocks as shown. Alright, so if we look at these in total, we've got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9 have been sold. Now it says what percentage of large blocks have been sold? There is 9 out of 12. Now when you cancel that down, you get 3 out of 4. And hopefully you remember that 3/4 is the same as either 0.75, which I times by 100 to give me 75%, or you just know that 0.75 is 75%. So there we go, 75%. Which of these can fold to make a cube. I love this type of stuff. Right, basically, if you try and visualize how this is going to happen, to be honest with you, the only one that's possible is this one here. And I know that because I've spent a lot of time teaching this topic, and there are certain ones that make a cube, and that is definitely one of them. If you were to try and imagine sort of putting any of those into a cube, they're not going to work except the first one. Kim drew a point. Then she drew a diagram to correctly show all the points on the page that are exactly 1 centimeter away from this point. Now this is called locus, right? So imagine I've got a point here and I attach a dog to a lead, and that lead is a particular way. Now that dog is actually going to be able to do a circle around, yes, which is what we call the locus of all points. So if we look at this one here, while that may be 1 centimeter, that certainly isn't. That's going to be more. What do you notice here? Closer, further away. They're not the same. Again, closer, sorry, far, close, far, close. So this is the only one where all the points could be what we call equidistant. So it's got to be this one here. This shape is made with 3 regular hexagons and 3 rhombuses or rhombi. Now basically what this question required you to know was that if you look at a rhombus, that can fit inside of a regular hexagon. And in fact, if I draw another one there, do you notice how that now looks like a 3D cube? Well, the fact of it is there are 3 rhombuses in each of those hexagons. So if we now know that there's 3, 3, 1, 1, 1, and another 3 there. So what we can now say, what fraction of the shape is black? Well, how many pieces are there altogether? 3, 6, 9, 10, 11, 12. There are 12 pieces altogether, and 3 of them are coloured in, which when we cancel that down gives me 1/4. Okay, now the only reason I know this question so quickly is basically because I had to do it earlier today. What is the size of the shaded angle? Now, the shaded angle, the easiest way to find that is actually to find the unshaded section here. Now to do that, because we're starting here, we're looking for the 0, which is on the outside, and then you're going to measure all the way around the outside until you read off this angle here. As it turns out, that's going to be 110 degrees. So this section here is 110 degrees. We want the shaded. So we know that angles in a circle add up to 360. I'm going to minus 110, which gives me 250 degrees. That answer there. The map is drawn to scale. It shows 4 routes from John's house to his school. The scale of the map is not shown. Which of the routes is the shortest distance? Now, I thought this was a bit tricky, a bit silly really. Now, the reason being is if we look at this distance here, it's exactly the same as that distance there. How many of you have gone out with a mate and you've walked around a square and ended up at pretty much the same place at the same time? Yes? What do we also notice? Well, I also noticed that this distance here is the same as that distance there. Okay, well, this distance here is the same as this distance here, and this distance here is the same as that distance there. So funnily enough, those yellow ones are exactly the same distance. So they can be discounted because, well, they just don't work. Changing my highlighter, let's see what we come up with now. Well, I think hopefully what you notice is that this journey that I'm pointing out now seems fairly direct. If we were to go, again, let's change my colour. If we were to go this one, we seem to be following that blue one but going further. Same distance. I don't think this is the same distance, slightly shorter, but longer. Same distance and longer. So it feels like for the green one we're actually going longer. So I would suggest then the dotted one is the one which is route 3 and colour in route 3. Sally has 10 hens. In total they drink about 3 litres of water each day. Whew. Approximately how much water would each hen drink in 1 week? Alright, so she's got 10 hens and they do 3, in total they drink 3 litres each day. Okie dokie. So how many days are there in a week? Well, there are 7, so they do 3 times 7, which is 7, 14, 21 litres in a week. So if we're going to try and find out how much each hen, so that's 1 hen, I'm now going to divide 21 by 10, which gives me approximately 2.1 litres. That's actually, well, I suppose that's quite a lot for a hen. We're supposed to be drinking that as humans. I don't think I'd drink that in a month. Ooh, water. This prism is half of a cube. A, B and C are 3 of its vertices, and a vertex is nothing more than a corner. What type of triangle is triangle A B, C? Cool, that's a good question. So a prism is half of a cube. So what we now know is that distance there and that distance there are exactly the same. But I'm going to say to you now that if I change my highlighter color again, that distance isn't going to be the same. So we're going to have two sides with the same lengths and one's different. And then basically that means that those two angles are the same, but this one here is different. And for a triangle that have two the same, I'm going to go with isosceles as the correct answer. And my brain is telling me, are you sure? Well, I am sure, because what it's telling me is it's half of a cube. So we know that this distance here is the same as that distance there. This distance here is the same as that distance there, which must mean those two green bits are the same. But that distance between A and B is definitely not the same. Ooh, that was an interesting question. Nikki solved the equation 3x minus 1 equals 4 correctly. Which of the following could be two lines of her solution? Well, the first thing I'm going to do is when I do this 3x minus 1 equals 4, I want to basically get rid of that negative 1. So I'm going to add 1 to both sides, which gives me 3x equals 5. All right, so basically there's either this one now or this one here as an option. And then what are we going to do? We need to divide both sides by 3 to give me 5 on 3. And so that there is my correct answer. In fact, it's the only one that's correct. This table shows the relationship between metric hat sizes and American hat sizes. What would the metric hat size be for an American hat size of 8? An American hat size of 8. So what we're going to do is we keep adding on 1/8 to get to a metric hat size. Okay, so if we got 56 as a size 7, and I'm going to add on 8 individual bits. If I now add on 8 to that, I'm going to get to a size 8. So 56 plus 8 is in fact 64. Now obviously you could have done that with fractions, yes, because we know that to go up half a hat size, we're adding on 4. So to go up another half a hat size, you would add on another 4, which would give you 64. Lots of different ways of thinking about that one as well. Right, this table shows the number of people at a party. What fraction of the females at the party were adults? So we want the fraction of females divided by the total number of adults. Right, so how many females were there? There were 10 females. Out of how many adults in total? Well, we would need to take the male and females together, which would give me 30. So it's 10 out of 30 would be my correct answer. Fraction of the females at the party are adults. There we go. Which of these is closest to the value of the missing number in this equation? So what we're going to try and do now is approximate. Yeah, so 59.65 is roughly 60. Divided by 3.14 is 3, and 78.5 is roughly 80. So let's see what we've got. Some number, let's call it x, plus 60 in brackets, divided by 3 equals 80. So I'm going to multiply both sides by 3 to get rid of that, which is going to give me x plus 60 is equal to 816,240. I'm going to get rid of the plus 60 by subtracting 60 from both sides, which gives me approximately 180. And there we go. So I'm going to treat that there as 180. Now again, interestingly, what you've got to notice is I rounded that up, I rounded that down, I rounded that up, and so roughly speaking my answer would be that. Mike joined some blocks together to make the edges of a 6 by 6 by 6 cube. In total he used 56 blocks. How many blocks would he need to make the edges of a 7 by 7 by 7 cube in the same way? Cool, that's a good question. Right, trying to work this one out then. Each of these 4 rows have 6 blocks. So you do 6 plus 6 plus 6 plus 6. Yeah, then what are we going to do? We then know that all of the other connectors are actually 4 blocks each. So 1, 2, 3, 4, 5, 6, 7, 8. So then we would add on 8 times 4. Let's just check that that makes right. Answer 6, 12, 18, 24 plus 8, 16, 32 gives me 56 blocks. Okay, so how would we do a 7 by 7 by 7 cube? So 6, 1, 2, 3, 4, 5, 6, 7. So we would end up with 7 plus 7 plus 7 plus 7. That would give us 1, 2, 3, 4, 5 in the middle plus 8 times 5. Okay, so what I've said now is if I was to replicate this Each of these would have 7 blocks in them, and then these connectors would have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 8 of them would all have 5. So that's the 8 times the 5 plus 7 times 7 plus 7 plus 7. So 7, 14, 21, 28. Plus 8 times 5 is 40. So we'll say 68. And again, there's probably another way to do this, but and if you know it, let me know. The fraction 1/8 equals 0.125 as decimal. What does 1/16 equal as a decimal? Well, basically 1/8 is, so 1/16 is half of that. So we want a half, so 0.125 divided by 2. Now the best way to do this, he says, is what? Move the decimal point 3 places. Gives me 125 divided by 2. So 2's into there goes 62.5. And then what I'm going to do is move the decimal point 3 places back. Yeah, it's much easier to get rid of the decimal point and then move it back. So I've got 62.5. I'm going to move it 1, 2, 3 places back. Gives me 0.0625. And believe it or not, I know this sounds ridiculous, but I'm actually going to check that because that's not one that I've not memorized 1/16 before. And guess what? That's correct. Whew, he says half of Caleb's money is equal to 1/3 of Ellie's money. Together they have $35. Half of Caleb's money is equal to 1/3 of Ellie's money. So half of Caleb's money is equal to 1/3 of Ellie's money. And together, so Caleb plus Ellie has $35. Whew. So that means Caleb is equal to 35 minus Ellie. Now I don't know if this is the way that you guys have been taught it, but we now have half of Caleb is equal to 1/3 of, oh no, try that one again. So what I'm going to do here is create a sort of an equation. So we know that a half of 35 minus E is equal to 1/3 of E. Multiply everything by 2 is going to get rid of, it's going to get rid of this. And that now needs to be a 2 on the top of there. Multiply everything by 3, gets rid of the 3 on the bottom there and becomes 3 there. Alright, so what does that give me? 2. So we got 3 times 35 is 95. Oh no, 3 times 35 is 5, 10, 15, 105. So we have 105 minus 3e is equal to 2e. So 105 is equal to 5e, and divide those by 5 gives me 21. So Ellie has $21, and I'm fairly sure there must be a much better way of doing this. Lisa measured the temperature of a substance every 5 minutes. The first measurement was minus 0.8, the second measurement was 1.8. For the third measurement, the temperature decreased by double the previous increase. Okie dokie. What is the third measurement? So we've gone from minus 0.8 to 1.8. So what have we gone up? We've gone up 2 degrees centigrade. So the third measurement, the temperature increased by double that. So times that by 2 gives me 4 degrees centigrade, but we have to add that on to the 1.8, which gives me 5.8 degrees centigrade. And the last question, Connor travelled from home to work to a country town. The 130-kilometre drive took 1 hour 30 minutes. He returned by the same route. Basically what that's telling me is they're going to go 130 kilometres back. The return drive took 1 hour and 45 minutes. So 1 hour 30 there, 1 hour 45 there. Right, average speed is total distance travelled divided by total time taken. So what was the total distance? Well, it's 130 there, 130 back, which is 260. An hour and 30 minutes. In many cases, it's probably going to be easier to do it in terms of minutes for the moment. Alright, we're going to do this in minutes and then convert. Okay, so 260 divided by 195. First thing we're going to do is divide that by 5. So 5's go into there 52 times. 5's go into there 5, 10, 15. 3 times with 4 left over. 45, 5, 10, 15, 20, 25, 30, 35, 40, 45. That's 9. So that's 52 on 39. Anything go into those? 13, I think. 13, 26. So we've got just check 13, 26, 39, 52. Yep, okay, so in which case 13 goes into that 4 times and goes into that 3 times. So that's 4 on 3, but that's kilometres per minute. So what we're now going to do is we're going to multiply that by 60. The reason I'm going to multiply that by 60 is to get me into kilometers per hour. So 4/3 times 60, 3's go into there, 20 times 4 times 20 gives me 80 kilometers per hour. And again, you may have found a quicker way to do that, but as far as I'm concerned, that is what I am going to do. Well, there we go. That's the end of the test. Hopefully you found this useful. I'll record the calculator one on another day. Take care. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye. Stay safe.